Welcome to our exploration of essential DevOps tools. In this session, we'll be diving deep into Jenkins and Kubernetes, two cornerstone technologies in the modern DevOps landscape. These tools have fundamentally transformed how organizations approach continuous integration, continuous delivery, and container orchestration. Let's begin with Jenkins, a tool that has revolutionized automation in software development. Following that, we'll explore Kubernetes and its powerful container orchestration capabilities. This combination of tools represents the backbone of many successful DevOps implementations across industries. Let's begin our exploration of Jenkins, a tool that has become synonymous with continuous integration and automation in the software development world. Jenkins represents a significant milestone in the evolution of DevOps practices, serving as an open-source automation server that has transformed how teams approach software development automation. At its core, Jenkins functions as a robust automation server, capable of handling virtually any aspect of the software development lifecycle. Think of Jenkins as an incredibly diligent and tireless team member who can handle repetitive tasks with perfect consistency. Whether it's compiling code, running tests, deploying applications, or performing system checks, Jenkins can automate all these processes with reliability and precision. The power of Jenkins lies in its ability to integrate with virtually any tool in your development stack. This flexibility comes from its extensive plugin ecosystem, which we'll discuss in more detail later. These plugins allow Jenkins to work with various version control systems, build tools, testing frameworks, deployment platforms, and notification systems. What sets Jenkins apart is its ability to create complex automation workflows while maintaining simplicity in its basic operations. For instance, you can start with a simple build automation task and gradually expand it into a sophisticated continuous integration and delivery pipeline as your needs evolve. Let's explore the compelling benefits that have made Jenkins a cornerstone of DevOps practices in organizations worldwide. These advantages have contributed to Jenkins becoming one of the most widely adopted automation servers in the industry. The continuous integration and delivery capabilities of Jenkins stand out as its primary benefit. Jenkins excels at automating the entire software delivery process, from the moment a developer commits code to its deployment in production. This automation ensures that code changes are regularly integrated, tested, and validated, significantly reducing the risk of integration problems and catching issues early in the development cycle. For example, a team can configure Jenkins to automatically build and test code every time a change is pushed to the repository, providing immediate feedback to developers. The extensibility and plugin ecosystem of Jenkins is truly remarkable. With thousands of plugins available, Jenkins can integrate with virtually any tool or service in your development stack. These plugins range from simple utility functions to complex integrations with cloud services, security scanners, and deployment platforms. This extensibility means that as your toolchain evolves, Jenkins can adapt alongside it, maintaining its central role in your automation strategy. Scalability and distributed builds represent another crucial benefit. Jenkins can distribute build and test loads across multiple machines, significantly reducing build times and improving resource utilization. This capability is particularly valuable for large projects with extensive test suites or complex build requirements. Organizations can scale their Jenkins infrastructure horizontally by adding more build agents as their needs grow. The active community support and continuous development of Jenkins ensure its relevance and reliability. With thousands of contributors worldwide, Jenkins benefits from rapid bug fixes, security updates, and new features. This community-driven development means that Jenkins stays current with industry trends and best practices, making it a sustainable choice for long-term automation needs. Let's examine the diverse ways organizations leverage Jenkins across different industries and use cases. Understanding these applications will help you identify opportunities to implement Jenkins effectively in your own environment. In the realm of continuous integration and continuous delivery, Jenkins serves as the backbone of automated pipelines. Organizations use Jenkins to create sophisticated CI/CD workflows that automatically build, test, and deploy applications across various environments. For instance, a typical pipeline might automatically build an application when code is pushed to the repository, run unit and integration tests, perform security scans, and deploy to staging environments for further testing. Automated testing represents another crucial application of Jenkins. Teams integrate various testing frameworks with Jenkins to automate different types of tests: unit tests, integration tests, performance tests, and security tests. Jenkins can be configured to run these tests in parallel, collect test results, and generate comprehensive reports. This automation ensures consistent test execution and helps maintain high code quality standards. The scheduling capabilities of Jenkins make it excellent for managing recurring tasks and cron jobs. Organizations use Jenkins to automate routine maintenance tasks such as database backups, log rotation, data synchronization, and system health checks. These scheduled jobs can be monitored and managed through Jenkins' intuitive interface, with automatic notifications when issues arise. In infrastructure orchestration, Jenkins plays a vital role in automating the provisioning and configuration of infrastructure resources. Teams use Jenkins to automate the creation and management of cloud resources, configure servers, and maintain infrastructure as code. This automation ensures consistency in infrastructure deployments and reduces the risk of configuration errors. Let's discuss the limitations and potential challenges of Jenkins, along with scenarios where it might not be the optimal choice. Understanding these constraints will help you make informed decisions about implementing Jenkins in your environment. The learning curve and complexity of Jenkins represent significant considerations. While Jenkins is powerful and flexible, mastering its configuration and maintenance requires substantial effort. Teams need to understand not only Jenkins itself, but also concepts like pipeline syntax, plugin configuration, and security settings. This complexity can be particularly challenging for smaller teams or organizations without dedicated DevOps resources. Resource requirements constitute another important limitation. Jenkins can be resource-intensive, especially when running multiple concurrent builds or using numerous plugins. Each build agent requires adequate CPU, memory, and storage resources, and these requirements can grow significantly as your build and test processes become more complex. Organizations need to carefully plan their Jenkins infrastructure to ensure optimal performance without excessive resource consumption. The lack of native support for containerization is a notable limitation in today's cloud-native world. While Jenkins can work with containerization tools through plugins, it wasn't designed with containers in mind from the ground up. This can lead to additional complexity when trying to implement containerized build environments or integrate with modern container orchestration platforms. Teams often need to implement additional tooling or workarounds to achieve seamless container integration. It's important to note that these limitations don't necessarily make Jenkins a poor choice. Rather, they highlight scenarios where careful consideration is needed. For instance, if you're working on a small project with simple build requirements, Jenkins might introduce unnecessary complexity. Similarly, if your primary focus is container-native development, you might want to explore alternatives that provide better native container support. Let's explore what it takes to get started with Jenkins and the prerequisite knowledge that will help ensure your success. Understanding these requirements will help you plan your Jenkins implementation effectively. The effort required to learn Jenkins basics is moderate but well-structured. You'll need to understand fundamental concepts such as jobs, pipelines, and plugins, as well as become familiar with the Jenkins user interface. While the basic concepts can be grasped relatively quickly, mastering Jenkins' more advanced features requires dedicated time and practice. Several key areas of prerequisite knowledge will significantly smooth your Jenkins learning journey. First, a solid understanding of software development concepts and practices is essential. This includes familiarity with different types of testing, code quality metrics, and deployment strategies. This knowledge helps you design effective automation workflows that align with development best practices. Experience with building and deploying software applications provides crucial context for working with Jenkins. Understanding build tools, deployment processes, and application architectures helps you configure Jenkins jobs effectively and troubleshoot issues when they arise. Proficiency with version control systems, particularly Git, is fundamental. Jenkins integrates heavily with version control, and understanding concepts like branches, merges, and pull requests is crucial for setting up effective CI/CD pipelines. Basic scripting knowledge, especially in languages like Groovy or shell scripting, becomes valuable when working with Jenkins pipelines. While Jenkins provides a visual interface for basic configuration, more advanced automation often requires custom scripts and pipeline definitions. Familiarity with CI/CD concepts provides the theoretical foundation for implementing effective automation workflows. Understanding concepts like build stages, test automation, and deployment strategies helps you leverage Jenkins capabilities effectively. Let's explore the valuable learning resources available to help you master Jenkins. These resources cater to different learning styles and experience levels, ensuring you can find the right path for your Jenkins journey. The official Jenkins documentation, available at jenkins.io/doc, serves as your primary resource for learning and reference. This comprehensive documentation covers everything from basic concepts to advanced features, including detailed guides for plugin configuration and pipeline development. What makes the Jenkins documentation particularly valuable is its practical approach, with numerous examples and best practices drawn from real-world implementations. Jenkins Essential Training on LinkedIn Learning provides a structured approach to learning Jenkins. This course takes you through the fundamentals of Jenkins, including installation, configuration, and creating basic automation workflows. The video format makes complex concepts more accessible, and the hands-on exercises help reinforce your learning. The Jenkins tutorials provided by Jenkins.io offer focused guides on specific aspects of Jenkins usage. These tutorials are particularly valuable because they're maintained by the Jenkins community and regularly updated to reflect current best practices and features. They cover both basic and advanced topics, allowing you to progressively build your Jenkins expertise. The Jenkins Plugins Index at plugins.jenkins.io is an invaluable resource for extending Jenkins functionality. This comprehensive directory helps you discover and evaluate plugins for specific needs, with detailed documentation and user reviews for each plugin. Understanding how to effectively use this resource is crucial for maximizing Jenkins' potential in your environment. Let's walk through the process of installing Jenkins on Windows systems. Installing Jenkins on Windows has been streamlined over the years, but there are important considerations to ensure a successful setup. The installation process begins by downloading the latest Jenkins Windows installer from the official Jenkins website. This installer is specifically designed for Windows environments and handles most of the setup complexities automatically. When choosing the installer version, you'll typically want to select the Long-Term Support (LTS) release for production environments, as it offers better stability. Running the installer executable follows a familiar Windows installation pattern, but there are several important choices to make during the process. The installer will ask you to select an installation directory, choose the port number for Jenkins to run on, default is 8080, and select the service account under which Jenkins will run. It's crucial to ensure that the service account has appropriate permissions for the tasks Jenkins will need to perform. The installation wizard will guide you through these steps, offering recommended options that work well for most situations. However, you should carefully consider any customizations needed for your specific environment, particularly regarding security settings and integration with other tools. After the installation completes, the wizard automatically opens the Jenkins configuration page in your web browser. This is where you'll perform the initial setup of Jenkins, including creating the admin user account and installing suggested plugins. This web-based configuration makes it easy to get Jenkins up and running quickly, while still providing the flexibility to customize your installation as needed. Let's explore the process of installing Jenkins on macOS systems. The macOS installation process has some unique characteristics that are important to understand for a successful setup. The installation begins by downloading the latest Jenkins macOS installer package from the official Jenkins website. This package is specifically designed for macOS environments and integrates well with the operating system's security features and service management system. Similar to Windows, you'll want to consider choosing the long-term support (LTS) version for stability, especially in production environments. When you open the downloaded PKG file, macOS guides you through a standard installation process. However, there are several important aspects to consider. The installer will request certain system permissions, which are necessary for Jenkins to function properly. These permissions are particularly important given macOS's strong security model. One unique aspect of the macOS installation is its integration with the macOS service management system. Once installed, Jenkins runs as a launch daemon, which means it starts automatically when your system boots and runs with appropriate system privileges. This integration ensures reliable operation and proper resource management. After installation, the Jenkins service starts automatically, and the Jenkins configuration page opens in your default web browser. This initial setup process is crucial for configuring your Jenkins instance, including setting up authentication, installing essential plugins, and configuring basic security settings. The web-based configuration interface makes this process straightforward, while still providing access to advanced configuration options when needed. Let's examine the process of installing Jenkins on Linux systems, particularly focusing on Ubuntu, one of the most popular Linux distributions for Jenkins installations. The Linux installation process begins with adding the Jenkins repository to your system's package sources. This involves importing the Jenkins repository key and adding the repository to your system's package manager. This approach ensures that you can easily update Jenkins through your system's standard package management tools. The installation commands for Ubuntu demonstrate the straightforward nature of Linux installation. The process begins with adding the Jenkins repository key using /ed, followed by adding the repository to the package sources. These steps ensure that you're installing Jenkins from official, trusted sources. After updating the package lists, installing Jenkins is as simple as using the apt-get install command. This command not only installs Jenkins, but also sets up the necessary service files and initial configuration. The package manager handles dependencies automatically, ensuring all required components are properly installed. One advantage of the Linux installation is its integration with the system service management. Once installed, Jenkins runs as a system service, which can be managed using standard system commands. This integration makes it easy to start, stop, and monitor Jenkins using familiar Linux administration tools. Let's explore how to create and manage Jenkins jobs, which form the foundation of automation in Jenkins. Understanding this process is crucial for effectively utilizing Jenkins in your development workflow. Accessing the Jenkins web interface is your starting point for creating and managing jobs. The interface is designed to be intuitive while providing access to powerful configuration options. When you first access Jenkins, you'll be presented with the dashboard, which gives you an overview of your jobs and their status. Creating a new Jenkins job involves several key steps. First, you'll click on New Item to start the job creation process. Jenkins offers several job types, each suited for different purposes. The Freestyle project type is excellent for beginners and simple automation tasks, while the Pipeline type offers more flexibility and power for complex automation workflows. When configuring your job, you'll need to specify various details such as the source code repository, build triggers, and build steps. Jenkins provides extensive configuration options, allowing you to customize every aspect of your automation process. This includes specifying when the job should run, what actions it should perform, and what should happen after the build completes. Building and monitoring projects in Jenkins is straightforward but powerful. The Build Now button manually triggers a build, while configured triggers can automatically start builds based on events like code commits or scheduled times. During the build process, Jenkins provides real-time console output, allowing you to monitor progress and quickly identify any issues that arise. Understanding how to properly uninstall Jenkins is just as important as knowing how to install it. A clean uninstallation ensures no remnant files or configurations are left behind, which is crucial for system maintenance and troubleshooting. For Windows users, the process involves stopping the Jenkins service first. This is important because active services can't be removed. I'll show you how to use the Windows Services console to stop Jenkins properly. Then, you'll use the control panel to remove Jenkins, but there's more to it than just that. I'll guide you through cleaning up remaining directories and registry entries that the uninstaller might miss. On macOS, uninstallation requires attention to both the application files and the launch daemon. I'll demonstrate how to use launchdelete to properly unload the Jenkins service before removal. We'll also locate and remove all Jenkins-related files, including those in your user directory that aren't automatically removed. For Linux users, particularly on Ubuntu, we'll use the package manager for removal. The -purge flag is crucial here as it ensures configuration files are also removed. I'll show you additional locations to check for Jenkins data, like /var/lib/Jenkins and /var/log/Jenkins. Remember, before uninstalling, it's vital to back up any important job configurations or build artifacts you want to keep. I'll show you how to export your Jenkins configurations and where to find critical data directories. As we transition to Kubernetes, we're moving into one of the most powerful and transformative tools in modern DevOps. Kubernetes represents the cutting edge of container orchestration, and mastering it will significantly enhance your DevOps capabilities. In this section, we'll explore how Kubernetes fits into the larger DevOps ecosystem. We'll discuss its role in container orchestration, how it complements tools like Docker, and why it's become the de facto standard for managing containerized applications at scale. I'll provide context about how Kubernetes emerged from Google's internal container management system, Borg, and how it has evolved into the open-source powerhouse it is today. Understanding this background helps appreciate the design decisions and architecture of Kubernetes. Get ready to dive deep into concepts like pods, services, deployments, and more. While Kubernetes has a reputation for complexity, we'll break it down into manageable pieces and build your knowledge systematically. In this section, we're going to explore what makes Kubernetes such a revolutionary tool in modern software development and deployment. Kubernetes, often abbreviated as K8s, represents a significant leap forward in how we manage containerized applications. Think of it as an intelligent orchestrator that conducts a symphony of containers across your infrastructure. Originally developed by Google, based on their years of experience running containers at scale, Kubernetes has now become the industry standard for container orchestration. What makes Kubernetes particularly powerful is its ability to automate the deployment, scaling, and management of containerized applications. Imagine having hundreds or even thousands of containers that need to work together seamlessly. Kubernetes makes this not just possible, but manageable. It provides a robust framework that helps you ensure your applications are running exactly as intended, across a cluster of machines that could be running anywhere, in your data center, in the cloud, or both. The platform's name comes from the Greek word for pilot or helmsman, which perfectly describes its role. It steers your containerized applications through the sometimes turbulent waters of modern infrastructure. As we proceed through this course, you'll discover how Kubernetes can transform your approach to application, deployment, and management, making your systems more resilient, scalable, and easier to manage. Let's explore the practical applications of Kubernetes across different industries and use cases. Understanding these scenarios will help you identify opportunities to leverage Kubernetes in your own environment. Microservices and containerized applications represent the most common use case for Kubernetes. Modern applications are increasingly built as collections of smaller independent services, and Kubernetes excels at managing this complexity. It handles service discovery, scaling, and load balancing automatically, making microservices architectures much more manageable. In the realm of continuous deployment and delivery, Kubernetes shines particularly bright. It integrates seamlessly with CI/CD pipelines, allowing teams to automate their entire deployment process. When a developer pushes new code, it can automatically flow through testing and staging environments before being deployed to production, all orchestrated by Kubernetes. The platform's ability to handle hybrid and multi-cloud deployments is becoming increasingly valuable. Organizations can deploy applications across different cloud providers or maintain a mix of cloud and on-premises infrastructure. Kubernetes provides a consistent platform across all these environments, reducing complexity and increasing flexibility. For high-performance computing and big data applications, Kubernetes offers robust capabilities for managing resource-intensive workloads. Whether you're running machine learning jobs, processing large datasets, or handling complex calculations, Kubernetes can efficiently distribute these workloads across your infrastructure while maintaining reliability and scalability. Let's explore the compelling benefits that make Kubernetes such a powerful tool in modern infrastructure management. These advantages have made it the de facto standard for container orchestration across industries. First, let's talk about scalability and availability. Kubernetes excels at horizontal scaling, allowing your applications to handle increasing loads by automatically adding or removing containers as needed. Think of it like having an intelligent assistant that monitors your application's needs and adjusts resources accordingly. This automatic scaling ensures high availability. If a container fails, Kubernetes immediately replaces it, keeping your applications running smoothly. The simplified application deployment and rollback capabilities are game-changing. Kubernetes uses a declarative model. You simply describe the desired state of your application, and Kubernetes works to maintain that state. Need to roll back to a previous version? It's as simple as declaring the previous version as your desired state. This approach dramatically reduces deployment risks and makes managing applications at scale much more manageable. Resource efficiency and optimization is another crucial benefit. Kubernetes acts like a sophisticated Tetris player, efficiently packing containers onto your infrastructure while ensuring each has the resources it needs. This optimization means you get the most out of your hardware investment, whether you're running in the cloud or on premises. Finally, the built-in service discovery and load balancing features make complex application architectures much easier to manage. Services can find and communicate with each other automatically, and traffic is distributed efficiently across your application instances. This removes a significant burden from developers and operators, allowing them to focus on building and improving applications rather than managing infrastructure. While Kubernetes is incredibly powerful, it's important to understand its limitations and recognize situations where it might be more than you need. This understanding will help you make informed decisions about when to use Kubernetes and when to consider alternatives. The complexity and learning curve of Kubernetes represents its most significant challenge. The platform introduces many new concepts and terminology, pods, services, deployments, and more. This complexity isn't just academic. It requires real investment in training and expertise. For small teams or simple applications, this learning curve might not justify the benefits. Resource requirements are another important consideration. Kubernetes needs a significant amount of computational resources just to run its control plane and supporting services. For small applications or development environments, these overhead costs might be disproportionate to the benefits gained. The operational overhead of managing a Kubernetes cluster shouldn't be underestimated. You'll need to handle monitoring, logging, security patches, and cluster upgrades. Without dedicated DevOps expertise, these operational tasks can become overwhelming. Understanding these limitations doesn't diminish Kubernetes' value, rather, it helps you make better decisions about its use. For complex, distributed applications at scale, the benefits often far outweigh these limitations. However, for simpler applications or smaller teams, alternative solutions might be more appropriate. Let's talk about what it takes to get started with Kubernetes and the journey ahead. Understanding the learning path and prerequisites will help you plan your Kubernetes adoption effectively. The effort required to learn Kubernetes is significant, but it's structured in a way that allows you to build your knowledge progressively. You'll start with fundamental concepts like pods, which are the smallest deployable units in Kubernetes, and gradually move to more complex topics like services and deployments. The YAML-based configuration files, while initially challenging, provide a declarative way to manage your applications. Your learning journey will be much smoother if you come prepared with certain prerequisite knowledge. A solid understanding of Docker and containerization is essential. After all, Kubernetes is a container orchestrator. You'll need to be comfortable with basic networking concepts, as Kubernetes heavily relies on networking for container communication and service discovery. Linux command line experience is crucial, as most of your interaction with Kubernetes will be through the kubectl command line tool. While graphical interfaces exist, the CLI provides the most powerful and flexible way to manage your clusters. The good news is that you don't need to learn everything at once. You can start with basic deployments and gradually expand your knowledge to more advanced features as your needs grow. Each concept you learn builds on previous knowledge, creating a natural progression in your Kubernetes journey. The journey of learning Kubernetes is well supported by a wealth of resources, and I'm excited to share some of the most valuable ones with you. These resources will help you continue your learning journey beyond this course. The official Kubernetes documentation at kubernetes.io is your primary reference. It's comprehensive, well-maintained, and regularly updated with new features and best practices. While it might seem overwhelming at first, you'll find it invaluable as you progress in your Kubernetes journey. For hands-on learning, Katakoda's Kubernetes scenarios provide an excellent interactive environment. These scenarios let you experiment with Kubernetes without having to set up your own cluster. You can try different configurations, break things, and learn from the experience, all in a safe, isolated environment. The Kubernetes by Example website offers practical real-world examples of Kubernetes configurations and use cases. It's particularly helpful when you're trying to implement specific features or solve common problems. Remember, learning Kubernetes is a journey, not a destination. The technology continues to evolve, and these resources will help you stay current with best practices and new features. I encourage you to bookmark these resources and refer to them regularly as you build your expertise. These resources, combined with hands-on practice, will help you build the confidence and competence needed to effectively work with Kubernetes in real-world scenarios. Now let's explore the various ways to install Kubernetes, which can vary depending on your operating system and specific needs. What's particularly interesting is how different platforms have evolved to make Kubernetes more accessible to developers. For Windows users, Docker Desktop has revolutionized the Kubernetes experience. By integrating Kubernetes directly into Docker Desktop, Windows users can enable Kubernetes with just a few clicks. This integration is particularly valuable for developers who want to test and develop Kubernetes applications on their local machines. The setup process is streamlined. After installing Docker Desktop, you simply enable Kubernetes in the settings, and Docker Desktop handles all the complex configuration behind the scenes. macOS users enjoy a similar experience through Docker Desktop. The installation process mirrors the Windows version, making it equally straightforward to get started with Kubernetes on a Mac. This consistency across platforms is particularly valuable for teams working in mixed development environments. For Linux users, the installation process might seem more complex at first, but it offers greater flexibility and control. The exact steps vary depending on your Linux distribution, but the official Kubernetes documentation provides detailed distribution-specific instructions. This flexibility allows Linux users to fine-tune their Kubernetes installation according to their specific needs. Remember, regardless of your platform choice, the end result is the same: a functioning Kubernetes environment where you can begin deploying and managing containerized applications. The key is choosing the installation method that best suits your needs and comfort level with system administration. Let's dive into one of the most practical aspects of Kubernetes: deploying and managing applications. This is where all the concepts we've discussed come together in real-world implementation. Kubernetes uses a declarative approach through YAML files, which might seem verbose at first, but offers incredible power and flexibility. Think of these YAML files as blueprints for your application's infrastructure. They describe exactly how you want your application to run, and Kubernetes ensures it maintains that desired state. When you create a deployment file, you're essentially telling Kubernetes several key things: what container image to use, how many replicas you want running, what ports to expose, and how to identify the components of your application. The example we see in the slides shows a basic deployment that creates 3 replicas of an application, ensuring high availability and load distribution. What makes this approach particularly powerful is its reproducibility. Once you've defined your application in YAML, you can deploy identical environments across different clusters, whether they're running in development, staging, or production. This consistency helps eliminate the "it works on my machine" problem that has plagued software development for years. Let's examine a practical example of a Kubernetes deployment file. This example will help you understand how Kubernetes configurations are structured and how they translate into running applications. The deployment file we're looking at demonstrates several key concepts. At the top, we specify the API version and kind of resource we're creating, in this case, a deployment. The metadata section gives our deployment a name, which is crucial for managing and referencing it later. In the spec section, we define how many replicas we want. Here it's set to 3, meaning Kubernetes will ensure 3 identical copies of our application are running at all times. This provides redundancy and helps distribute load across multiple instances. The selector and labels sections might seem redundant at first, but they serve an important purpose. They create a logical grouping of pods that belong to this application, allowing Kubernetes to manage them as a unit. This labeling system is fundamental to how Kubernetes organizes and manages resources. The container specification details exactly what should run in each pod. We specify the image to use, what we want to call this container, and what ports it should expose. This level of detail ensures consistency across all instances of our application. Now that we understand the structure of a Kubernetes deployment file, let's walk through the process of actually deploying and managing an application in Kubernetes. This is where theory meets practice, and you'll see how Kubernetes command line tool, kubectl, makes management straightforward. The first step is applying your deployment configuration using kubectl apply -f myapp-deployment.yaml. This command tells Kubernetes to create or update resources based on your YAML file. What's powerful about this approach is that it's idempotent. You can run it multiple times, and Kubernetes will intelligently handle the updates. After applying the deployment, you'll want to verify that everything is running as expected. The kubectl get deployments command shows you the status of your deployments, while kubectl get pods lets you see the individual pods that make up your application. These commands are essential tools in your Kubernetes toolkit. One of the most important steps is exposing your deployment as a service. This creates a stable endpoint for accessing your application. The command kubectl expose deployment creates this service, making your application accessible to other components in the cluster or, if configured appropriately, to the outside world. Finally, you can retrieve the service IP using kubectl get service myapp. This IP address is how other applications or users will connect to your service. Depending on your cluster configuration, this might be an internal IP or an external load balancer address. Remember, these commands are just the beginning. As you become more comfortable with Kubernetes, you'll discover more advanced commands and options that give you greater control over your deployments. The key is to start with these basics and gradually expand your knowledge as your needs grow. Welcome to our final section. Before we open the floor for questions, let's take a moment to review the comprehensive journey we've taken through Kubernetes and its capabilities. We began by understanding what Kubernetes is, an open-source container orchestration platform that has revolutionized how we deploy and manage applications. We learned that its name comes from the Greek word for helmsman, reflecting its role in steering and managing containerized applications. Let's recap the key areas we've covered. Core benefits. We explored how Kubernetes provides exceptional scalability and high availability. We discussed its simplified deployment and rollback capabilities. We learned about its efficient resource management. We covered its built-in service discovery and load balancing features. Real-world applications. We saw how it's used for microservices architectures. We discussed its role in continuous deployment. We explored its capabilities in hybrid and multi-cloud scenarios. We looked at its use in high-performance computing. Important considerations. We acknowledged the learning curve and complexity. We discussed resource requirements and when Kubernetes might be overkill. We covered the operational overhead involved in maintaining a cluster. Installation and setup. We walked through installation processes for Windows, Mac OS, and Linux. We learned about different setup options and requirements. We covered basic cluster configuration. Practical implementation. We examined detailed YAML configurations. We practiced creating deployments. We learned about service exposure and management. We covered basic troubleshooting and verification steps. Remember that working with Kubernetes is a journey of continuous learning. The platform is constantly evolving, and each question you ask helps deepen your understanding. No question is too basic or too complex. Every query helps build a stronger foundation in container orchestration. What aspects of Kubernetes would you like to explore further? Perhaps you're curious about specific use cases in your organization, or maybe you'd like to dive deeper into certain features we've discussed. Don't hesitate to ask about real-world scenarios or practical challenges you're facing. Thank you for your attention throughout this course. Your questions and participation will help everyone gain a better understanding of this powerful platform that's reshaping the landscape of modern application deployment and management.